To our fellow students, Engineer Al, good day. Introducing Daven Felix, Maria Lucille Camallere, Chrissha Saragena, Jerlyn Jabanes, and I am Maria Queenie Medina, and we are the reporters who are going to discuss about the replacement analysis, where it is the application of equivalent uniform annual cost and annual benefit to alternatives with unequal lives. Okay, we have Miss Chrissha Saragena, who are going to talk about the introduction of replacement analysis.
At one time or another, an enterprise will meet with the problem of replacing some or all of its equipment. No equipment lasts forever. Maintenance and repair costs usually increase, thereby making the further operation of equipment uneconomical. Better devices may be invented which can be operated more economically. As a result, old equipment have to be replaced in order to compete with others in the same business who may install the newer equipment. So this is our topic. It is about replacement analysis, where it is a decision concerning whether an existing asset should be replaced by a newer version of the same machine or even a different type of machine that has the same functionality as the existing machine. So there are two reasons for replacement analysis. First, decrease in physical efficiency. So decrease in physical efficiency refers to changes in physical condition of an equipment resulting in less efficient. So as what I have said earlier, that there is no equipment that lasts forever. Maintenance and repair costs usually increase. So it is uneconomical siya, which is na mga better devices na na-invent which is more efficient. Second is obsolescence. This refers to changes in conditions external to the equipment under consideration. Equipment may become obsolete, such as the demand of this product manufactured on the equipment may decrease or disappear entirely. So diri na mosulod na mag-decide na magpalit og bag-o which is more efficient, has lower operating expenses, and perhaps have greater capacity kay bag-o naman siya. So mas upgraded na siya compared sa daan.
Alright, so the next reporter is Mr. Daven Felix, who are going to discuss about the instances of replacement analysis.
So, instances of replacement analysis. Here are the 5 instances. First is replacement due to constantly increasing maintenance cost. Second is replacement due to declining efficiency. Third is replacement due to inadequacy. Fourth is replacement due to obsolescence. Last is the replacement due to combination of causes. So first is the replacement due to constantly increasing maintenance cost. The parts of a piece of equipment wear out at varying rates in most cases. A high level of efficiency is maintained by repairing or replacing the worn-out parts when necessary. Certain repairs are minor, and these often occur during early life of the equipment. But as the time goes by, more expensive repairs are needed. These require higher maintenance costs. If this become excessive, replacing the equipment is due for consideration. So for example, ani is kanang imong equipment or device kay suddenly nagadaot-daot siya, then na need na pyesa or part sa equipment da paliton. Then pag sugod ato kay sige na siya og kabalikan o kaguba, then makadugay na obviously kay magkadako man gyud ang maintenance cost kay nagkadaghan naman ang repair sa equipment. And from that point, it's up for you to decide kung asay mas efficient, kung palitan pa ba og mga bag-ong pyesa ang equipment or magpalit na lang jud og bag-ong equipment. So the second is the replacement due to declining efficiency. Most, if not all, equipment decline in efficiency through age and use. For instance, pipes used in industry become corroded due to the chemical action of gases and chemicals. They became early leaky. They become leaky if a pipe becomes badly corroded. Repairing the leaks becomes inadequate. Replacement is the only solution. So, for example, ani is kanang equipment na medyo mga may edad na dyan. And for sure, ang efficiency niya is nagka-lessen na from time to time as nagkataas ang usage sa equipment. So, tungod sa kadaan niya na ay mga ubang equipment na dili na jud maayo, and ang only option na lang ana is magpalit na lang jud og bago nga equipment. Then third is the replacement due to inadequacy. Inadequacy of a piece of equipment occurs when it cannot perform the service required, or even though it is still in excellent condition. So, ang example ani is kaning if imong equipment nga napalit kay as the time goes by kay nausab na and dili na siya efficient gamiton para sa iyang purpose. For instance, ang blade sa grass cutter or lawn mowers. Sa una, sa sugod na yung palit kay dali ra kaayo ka mahuman sa imuhang trabaho tungod sa efficient pa siya, then efficient pa kay siya gamiton, then hait pa jud kay ang blade. So obviously dali pa ka mahuman sa imo mga trabaho. Pero karon ka na maglisod na ka og tiwas sa imong task kay tungod ang blade sa equipment kay habol na or dull na. Then mo na ang time nga mag-decide ka kung mas na magpalit ka og bagong blade para sa imong task, para mas mapadali or efficient ang imong trabaho. Fourth is replacement due to obsolescence. Improvements in equipment may be so rapid and extensive that it may be wiser to scrap relatively new piece of equipment and replace it with new modern improved version. So na mga times or instances na ang equipment is daan na jud kaayo, then na ay mga piyesa nga mapalit kay lisod na jud kaayo pangitaon if magkabuang ang imong equipment. So sa kanina time is much better kung magpalit na lang ka og bagong equipment, then i-dump na lang ang daan nga equipment which is di na mapalitan og bagong nga piyesa tungod sa kadaan na sa equipment, and wala na kay makitang piyesa nga gi-manufacture tungod sa kadaan sa equipment. And lastly, the replacement due to combination of causes. In most cases, replacement is forced by two or more of the above causes. The efficiency of equipment declines with age. Maintenance cost becomes excessive. Better equipment are designed. Changes in capacity occur. All of these combine to necessitate replacement. So, any combination of the first four reasons is mo'y naga-cause sa replacement sa equipment. For example, nanay mga bagong equipment nga design kumpara sa imong equipment which is more efficient na siya gamiton kaysa sa imuha, then mo na time na magpalit ka og bago. And the changes of capacity, mas dako og capacity ang bago nga equipment karon kaysa sa imuhang so much better if magpalit na lang pud ka og bago nga equipment, and so on sa mga reasons na kailangan na palitan ang imuhang mga equipment. So that's all.
Okay, so next is sunk cost due to unamortized value. So know that sunk cost is an expenditure that has already been incurred or cannot be recovered. So, unamortized value of equipment is defined to be the difference between its book value and its resale value when it is replaced. Suppose that a certain piece of equipment has a book value of 1,000 pesos. Due to the reason previously mentioned, it becomes necessary to replace it. If the most it can be sold is only 750, then the unamortized value is 250 pesos. So the proper procedure or accounting procedure to record this amount is i-consider natin siya as a sunk cost or a loss. So this sunk cost has occurred due to unforeseen events that were not anticipated in setting up the depreciation fund. It is erroneous to use the book value of the old equipment in replacement studies. Using a book value greater than the present resale value of the equipment will cause the annual costs for the new equipment to be less than what they are. Thus, if such annual cost na magagamit para matukoy natin ang selling price ng product, ang result will be a price less than actual and will cause further losses. So, malulugi talaga. Mali din na ita-charge natin ang sunk cost dahil sa unamortized value sa cost ng replacing equipment. This would ignore the fact that whether ang old equipment is replaced or not, ang sunk cost ay nangyayari na. So it therefore has no place in the cost of the new equipment if replacement is made. So furthermore, charging the sunk cost to the new equipment will cause the annual costs to increase, thereby forcing the manufacturer to increase the selling price. So in case there are no other manufacturers of the same product, so this procedure may be done. But where the industry is highly competitive, the manufacturer may not be able to sell his products at the higher price. Thus, he will be pricing himself out of the market. Alright, so we have the defender and challenger concept. So to facilitate the analysis of replacement problems, two terms, the defender and challenger, were introduced in the publications of George Terborg of the MAPI, or the Machinery and Allied Products Institute. These terms are defined as follows. So the defender it is the existing asset which is being considered for replacement. And the challenger is the asset which is proposed to replace the existing asset. It is performed, or the replacement analysis is performed in a manner similar to the comparison of alternatives discussed, with the exemption that one alternative is to keep the existing asset, which is the defender, right? And the other alternative is to consider its possible replacement, which is the challenger. The cash flows and the lives of the defender and the challenger are usually quite different. So assets which are candidates for replacement or retirement have low capital costs, while operational costs are often high and increasing. So the reverse is true for new assets, which usually have high capital costs but low operating costs. Next is the minimum cost life. In certain replacement problems, it would be advantageous to know the number of years an asset should be used, during which time the total annual cost would be decreasing until a minimum amount is attained. So after this period, the annual cost will continue to increase. Good management dictates that such an asset be replaced at this time before annual operating costs become excessive. So we have Miss Jerlyn Jabanes and Maria Lucille Camallere who are going to give some examples of the problems about the replacement analysis.
So here are the sample problems for the replacement analysis. Problem 1. For the minimum cost life of an asset with the first cost P, zero salvage value for any year N, where N is the life of the asset and years, and whose annual operating cost for the first year is B increasing by a uniform gradient G every year thereafter. So here we need to derive a formula. But first, we need to clarify and define the meaning of the symbols used. So our P here is the first cost of the asset. Our B is the operating cost of the asset for the first year. Our G is the amount of uniform gradient. Our N is the life of the asset in years. And another N is the life of the asset for minimum annual cost. TAC is the total annual cost for N years. AOJ is the annual operating cost in years. In order to get the average first cost, we need to use a formula P over N. Then in order to get the average operating cost, we will be using J is equals to 1 over N is equals to B plus N minus 1 times 0 plus G over 2. In order to get the TAC, we need to add the average first cost plus the average operating cost, which we can derive P over N plus B plus N minus 1 over 2 times G. To obtain the life N for minimum total cost, we differentiate with the respect to N and equate the derivative to 0. Thus, D multiplied by TAC over DN is equals to negative P over N squared plus G over 2 is equals to 0. Now we can use the formula for the life of the asset for minimum annual cost. N is equals to square root of 2P over G. So here is the set of another problem. A machine was purchased for 150,000. It is expected to have zero salvage value and a life for 10 years. The operating for the first year is 12,500 and will increase 500,000 every year thereafter. If interest is equals to 0%, determine the number of years the machine should be kept. So based sa problem, ang atuang pangitaunon kay ang life of the asset for the minimum annual cost. So first is atuang pangitaon ang atuang given. So our first cost of the asset is 150,000 kay gi-purchase po nato siya. Then ang atuang gradient kay 5,000 since mag-increase man siya every year. Tapos, ayaw, mao lang na ang inyuhang kwaon because mao lang man ang ato ang needed. Sabdo lang nato ang problem para dili na ta maglibog sa ubang numbers na given. So, we will be using the formula N is equals to square root of 2P over G. So, our 2 here, kay constant na siya ha. Then, we need to substitute all the given. So, square root of 2 times 150,000 over 5,000. And now, we can get the answer 0.75 or approximately 8 years. Then, now we can conclude that the number of years the machine should be kept is 8 years.
Problem number 3. A company purchased a numerically controlled machine for a manufacturing process 3 years ago. It is expected to be used for 3 more years, with annual operating cost of 4,500. However, due to rapid technological improvement of such mass, better machines are now available. Data for 2 possible replacements machines A and B and the defender are as follows. So we can see the data given by the problem, the, by the defender, value of the defender, machine A and machine B, with the first cost, salvage value, life in years, annual operating cost, and trade-in value of the defender. So earn if invested capital must earn 16%, determine which machine is more economical. So the solution for this can be seen in the next slide. So determine the annual cost of each machine. So first is we must determine the annual cost of each machine. First, compare na to ang defender with machine A with the formula of annual cost of defender is equal to 10,000, I, which is the interest, then N is the number of years. So the formula is A is equal to P times interest 1 plus I over to the power of N over 1 plus I to the power of N minus 1 plus 4,500. So we reach the answer of 8,953. The next is the annual cost of machine A. 32,000. A is equal to P times I to the power plus I, 1 plus I to the power of N plus over 1 plus I to the power of N minus 1 minus 5,000 AF, which is A is equal to F times 1 over 1 plus I to the power of N minus 1 plus 3,200 with the interest rate of 16% and the number of years for 10 years. So we reach the answer of 9,539. So as we can see that 9,539 is greater than 8,953. So next, i-compare na to ang defender with machine B since humana na to nakuha ang machine B. A, I mean. So, for the same formula, annual cost of the defender, i-change lang nato ang value nga given sa machine B. So, 12,000. Ang interest niya is 16. Number of years is 15. Plus 4,500. And then, we get the answer of 9,843. Annual cost of machine B is equal to 45,000 AP. So the same process with the machine A. Then plus 2 subtract siya sa 9,000 EF. A is equal to F times 1 over 1 plus I to the power of N minus 1. 16% iyang interest rate. Then 15 years iyang life in years. And then i-add ang 3,600 of the annual operating cost sa machine B. So we get 11,449. So 11,497 is greater than 8,953. So the conclusion is, since the annual cost of machine A and B exceeds those for the defender, it is more economical to continue using the defender for its remaining life for 3 years. Problem number 4. A plastic extrusion machine purchased 4 years ago has annual operating cost of 12,000 pesos and is estimated to have a service life for 6 more years out with this salvage value of 4,500 pesos. A new machine with the same output will cost 42,000 pesos with annual operating cost of 7,200, a life of 12 years, and a salvage value of 6,000 pesos. For this class of asset, the manufacturer expects an 18% rate of return. Determine the minimum trade-in value that the manufacturer should receive and still purchase the new machine. So, the solution of this problem, so in this case, we determine the trade-in value such that, so we can, the first equation is that annual cost for Defender is equal to the annual cost of the Challenger. If the actual trade-in value for the Defender is greater than sa ma-obtain nato sa equation 1, which is the annual cost for Defender, annual cost for the Challenger, the asset should be replaced. So, we denote by X. So, mauna siyang na ay X dira, kay gidenote nato na siya. So, gidenote nato ang minimum trade-in value for the Defender. So, we get, so ang formula to gamiton kay annual cost for Defender is equal to X, which is gikan nga to nga gidenote katong giyon ako ganiha, the minimum trade-in value for the Defender, then AP, which mean the A is equal to P times interest, 1 plus interest to the power of n over 1 plus interest to the power of n minus 1, which is ang iyang interest rate is 18%, tapos ang iyang number of years is 6, subtract to 4,500 AF, so A is equal to F, 1 over 1 plus interest to the power of n minus 1, 18%, tapos 6 years plus 12,000. So, mo ni siya nakuha ang equation 1, 0.28591x plus 11,523. And then, so equation 1, which is na ang x. Makita na itong ang x. Then, annual cost for Challenger, 42,000. Tapos, so annual cost for the Challenger is equal to 15,791. So, equate na to siya, which is nanatay value sa annual cost of Challenger, kay equal man ang annual cost for the Defender is equal to the annual cost of the Challenger. So, mo to siya itong gamiton. So, 0.28591x, nga gidenote na to siya sa minimum trade-in value for the Defender, plus 11,523 is equal to 15,729 sa annual cost for the Challenger. So, ang value sa X kay 14,928. So, if the trade-in value for the Defender exceeds this amount, then the Challenger should purchase the machine.
So, problem number 5.
It costs a plant 2,000 a day caused by a shutdown of its equipment. Past records show an average of 3 days shutdown each year. To avoid future shutdowns, it is proposed to purchase a standby machine for 25,000 pesos, which is expected to have a service life of 12 years with 5,000 salvage value at the end of this time. So annual maintenance and operation for 3 days would cost 1,200 pesos. Would it pay to buy the standby machine if the minimum required rate of return is 15%? So the solution for this problem is, so first solution by the annual cost method. Cost of shutdown, so 3 days times 2,000 is equal to 6,000. So annual cost of standby machines, depreciation, 25,000 minus 5,000, 15% interest, 12 days ang iyang number of time. Wait lang. Wait. So, 12 years a service life. So, Operation and maintenance, 1,200. Minimum rate of return, so 15%. I-multiply nito siya sa 12,000, so 3,750. Total annual cost, 5,640. So, to prevent shutdown, it is better to purchase the standby machine. So, the second solution, using the rate of return method. So, first, atong gigawit kay annual cost method man. So, karon is the rate of return methods. Mention second solution. So, excluding the minimum rate of return. Minimum rate of return, which is 3,750. Annual cost is equal to 690 plus 1,200 is equal to 1,890. So savings by purchasing the standby machine is equal to 6,000 minus 1,890 is equal to 4,110. Investment in standby machine is equal to 25,000. So rate of return on investment, ROI. So RRI is equal to 4,110, which is the savings by purchasing the standby machine over 25. I divided by 25,000, which is the capital. Then i-multiply na to siya sa 100 para makuha na to ang interest rate. So is equal to 16,444%, which is greater than siya sa minimum rate of return na 15%. So the decision is, since it is greater than the minimum rate of return, it is better to purchase the standby machine. So that's all about our report for the replacement analysis. So if any clarification, correction, violent reaction, andam kay mimudawat, so kay we know nga dili dyan na perfect ang mga report. We just do our best para mahatag na mo ang information maskin dili siya perfect. So mudawat me basin na may mga correction, andam jud kay mudawat sa inyong mga correction ug mga basin na may question pero hinaot unta wala. So mao lang to, daghang salamat.